oh, it's not started yet. It's like being back on lockdown, isn't it? Yeah. Right, so we've previously looked at molecular formula. So molecular formula include working out the formula for ionic compounds. So that's the topic we did using the table of ions. And also, there's a few other molecules that you need to be aware of, like water, H2O, carbon dioxide, CO2, etc. Okay, so those are what we know as molecular formula. And they tell us exactly what is in a molecule. Okay, so they tell us that in, for example, a molecule of sulfuric acid, H2SO4, that there are 2 atoms of hydrogen, 1 atom of sulfur, and 4 atoms of oxygen. Okay, and that's the formula that we come across most frequently. However, there's another form of formula known as the empirical formula. Okay, and this is a formula. Come on then, Bella. This is a formula that tells you the lowest ratio of atoms in a particular molecule. Okay, the lowest ratio. So let's sort of explain what we mean by that with an example. Okay, so the empirical formula is the lowest ratio of atoms in a compound. Your books, it's in this box here then, Bella, yeah? Okay. So, for example, in water, which we know to be H2O, that there is both the empirical formula and the molecular formula, okay? Because there are 2 hydrogen atoms, 1 oxygen atom, okay? And you can't mathematically make that ratio any smaller, can you? Okay, you've got 1 oxygen atom there, and therefore that's the lowest number of oxygen atoms you can possibly have. So this is the molecular and empirical, okay, formula. And this is because there is no lower ratio of atoms possible. So that's an example there where the molecular formula and the empirical formula are the same. However, if we take another example, and it's one that came up in the sheet we did on simple molecules, look at the big A3 sheet that we had. If we look at hydrogen peroxide, which is a big brother of water, if you like. So can anyone either recall or find the formula for hydrogen peroxide? It's on the big A3, sorry, fold-out sheet we did. Excellent, Tempe. Yeah, so hydrogen peroxide has a formula of H2O2. Okay. Now, that's the molecular formula. That's the formula that we recognise. That's the formula that's on that sheet. It's the one that you use to create a diagram of hydrogen peroxide. Okay. Can anyone suggest, however, what the empirical formula is based on what we've said so far? What's the empirical formula for hydrogen peroxide? What's the lowest ratio of atoms possible? Fedi? HO. Excellent. Okay. So the empirical formula is simply HO. Okay. It's if we divide both of these values by 2, we end up with HO, don't we? Okay. So that's the empirical formula. So this here would be the molecular formula. This is what actually, if you were able to actually look at an individual molecule of hydrogen peroxide, if we had the means to do that, you would find that hydrogen peroxide does consist of 2 atoms of hydrogen and 2 atoms of oxygen. However, from a mathematical standpoint, its formula could actually be expressed as HO, okay, because the ratio of hydrogen to oxygen is 1 to 1. So the empirical formula is HO, and in a similar vein, because this is the lowest, that's the lowest it says there, believe it or not, ratio of hydrogen to oxygen. Now, we reasonably frequently find that the molecular formula and the empirical formula are the same, okay, but there are instances like hydrogen peroxide where it's not. Now, the main focus of this particular idea in your exams is being able to calculate the empirical formula of a compound using quite a prescriptive method, quite a simple method. The questions that come up on this topic are often very similar. So if I just show you an example of such a question, if I get the right screen, where are we? There we are. So I've trawled through the WJEC question bank, which is a publicly available website. And when you get sort of into your revision towards the end of next week, maybe, or later on in your sort of career in school, certainly towards the summer, it's a very good website to look at, the WJEC question bank, because you can find individual questions on any topic from any of your subjects. It's not just science, it's not just chemistry, it's all your topics, okay? So it's something to bear in mind. And so I did a quick trawl, and I found these two questions here, which are typical of the sort of thing you should expect in your GCSE exams for empirical formula. So we'll take this second one as an example. So this is a part question. It's set in the context of other information. So it says there, oxides of nitrogen are released in vehicle exhaust fumes. They can cause smog in busy city centres as well as acid rain. So that part of the question is just an introduction. And then it goes on to say, one oxide of nitrogen contains 30.4 grams of nitrogen and 69.6 grams of oxygen. So that sort of information can be worked out experimentally. If you know what you're doing, you can take a sample of a compound and you can find out what mass of individual atoms are present in it, sorry, what mass of individual elements are present in it, okay? And then from that, you can calculate the empirical formula, okay? Now, I need to show you how to do that, and it's this skill that you will need to learn, okay? So I'll write down, just make a copy of that information there. So we've got, I'll put this down here, example calculation. And we've got 30.4 grams of nitrogen. And we've got 69.6 grams of oxygen. So that's the key information you need, is the mass of the elements involved. And I think at GCSE, it's likely to be only two elements that you need to worry about, okay? And you'll notice it gives you in the question the atomic mass of each of these elements. You would have access to a periodic table as well, but just to make it as straightforward as possible, they do give you the atomic mass, which is no mistake. You need that information to calculate the empirical formula for this compound, okay? So this is information that will be provided in the question, and the method by which you need to use that is as follows, okay? So I would generally use a table, okay? So we'll go for empirical formula table, okay? And this table I tend to lay out as follows. So we've got the first column is your instruction, and then we've got a column for the elements that you're asked to calculate, okay? So this one involves nitrogen and oxygen. Sorry, I was a bit quick there. Do you want to make a copy of that information there at the bottom? Okay, so that's the information that we're basing on. That's the base of the question. We need to work out the empirical formula of this compound using this information. If you just want to write that down, I was a bit quick moving on there. We okay? Okay to move on? Right, so with that information in mind, first thing I tend to do is to draw a simple table, okay? Now I say instruction, it's a bit vague, that title. I'll see what I mean in a second. So the first bit of information I would put in here is the mass given in the question, okay? So I started to write percentages there. So the mass in our question, memory like a sieve, is 30.4 for the nitrogen, and it's 69.6 for the oxygen. So that's given to us in the question. And then I would quote the atomic mass of each of these elements, okay? So the atomic mass of nitrogen is 14, and the atomic mass of oxygen is 16. So far all we're doing is rewriting the information given to us in the question. But then the first actual thing you need to remember that you need to do is to divide by the AR. So you divide the mass by the AR. Okay, so actually I should have written that mass divided by AR. So if you can make yours a little clearer than mine, because I got a bit carried away there. Okay. So if we do 30.4 divided by 14, okay, and why calculators insist on giving us a fraction the first time these days, I have no idea. Okay, so that's 2.174285. Now, the information we were given here is to 3 significant figures, so I would advise that we quote any answers to 3 significant figures as well. We can't quote that level of accuracy there because our starting data isn't that accurate. So to 3 significant figures, that would be 2.17. And then we do the same with the oxygen. Okay, so we do 69.6 divided by 16. Okay, and that gives us 69.6 divided by 16. Press the right button. Is 4.35. 4.35. And then hopefully the final stage is we simply divide by the smallest of these two numbers. Okay, so we divide by the smallest. Okay, so in this particular case, obviously 2.17 is the smallest. So what's 2.17 divided by 2.17? 1. Okay, so 2.17 divided by 2.17 is 1. And then 4.35, you can probably work out what the answer is going to be, but we'll go through the process on the calculator. 4.35 divided by 2.17 is 2.004, okay, which is to all intents and purposes is 2. Okay, so these numbers here we've created by dividing by the smallest number from that process there. So with that in mind, would anybody like to suggest what the empirical formula is for this oxide of nitrogen? What's the empirical formula? We've worked out there a ratio of atoms. Go on, Ferrier. NO2. Yeah, NO2. So we've got 1 nitrogen, 2 oxygens. So as a formula, we would write that as NO2. So that's the empirical formula. Okay. So does anybody have any questions on that? It's you have to learn this skill, this process of dividing the mass you're given by the atomic mass and then dividing those answers by the smallest of the answers. Yeah, so it's Bella's looking puzzled. Okay, so are you happy with these figures here? These were provided by the question. Yeah, these numbers here, these are the masses of nitrogen. So if you've looked those up on the periodic table, or indeed, if you remember, they did give them to us in the question, didn't they? So in the question, which was there, they tell us that the mass of nitrogen is 14 and the atomic mass of oxygen is 16. Yeah? Okay, so those are provided in the question. And then, so the first stage, this is the new bit, the bit that you need to remember, is you then divide that by that to get this number, and you divide that by that to get this number. Then you divide both of these by the smallest of them. Yeah? And that gives you the empirical formula. Okay? Yep. Right, so in the best tradition of this type of lesson, I've got some questions for you to have a look at here. Now, there's 7 questions. I don't envisage everybody doing all of them, but what I want you to do is have a go at them and see whether you can apply this method to the questions on this sheet. So I'll just stop the recording at that point.